Another draft science video presentation. Okay, I had a slight technical glitch, so I'm gonna, instead of having to edit a video and splice it together, which will probably take longer than 16 minutes, I'm gonna play the part of the video that's salvageable, and yeah, maybe I can add some value to it, but whatever, and then I'll make the extra part. Something like that anyway. So, let us continue. Another draft science video presentation and such. So we'll do a couple of comments, kind of on subjects, anyway, that I don't want to make it a habit on this video. It's stay to the science. I don't want to make it a habit on this channel, I should have said, so, pretty flawed beginning. Stuff, physics related in a kind of a narrow, well, whatever. It's hard to narrow it because it's all getting one thing wrong gets everything wrong, and blah blah blah. They're all related subjects. Yes, it's all physics in the end, but I'm focused on physics in terms of the bigger story of like gravity, kinetic energy, what are photons, that kind of physics, and not big picture, what it means to living organisms picture. So at Todd Q, I fully understand what you are asserting. I'm not sure you do. But anyway, I think that these ontological videos are really your strong suit. They're all, every video, there's no such thing as anything other than... frankly, this whole pretentious language of calling storytelling ontology is just really irritating. Describing events, we don't need a special word for it. Say the extra language, use the extra phrases of describing the chain of events. That would be better. Just say it. Ontology. Just sounds like bullshit coming. It's the smell of bullshit, the word ontology. Telling a story in terms of an argument. You're explaining, X, Y, Z, the constituents of why it makes sense. It's all ontological, but whatever. It's all a recipe, and you're just describing, the sequence of the recipe and the byproducts of the events and blah, blah, blah. And it's just, that's all there is. Whoops. Let's see if I can make some more mistakes. And then this word just threw me. Okay, I am an atheist, so I have no religious axe to grind. It's not about... So apathetic is what he's saying, right? He's apathetic on the subject of religion. There's no apathy to theology. Theology is the same as saying fabology. And to be apathetic, to be indifferent to whether somebody's telling you something based on good reasoning and good evidence or telling you something based on completely made up shit, you shouldn't be apathetic. Having an axe to grind. It's about whether, you're telling me, or you're basically saying, I don't have the ambition, or the sense to say I'm anti-fabulist. I'm against just making up silly stories and calling it truth-seeking. Atheist means anti, essentially, and it means no interest in. You could even say you're apathetic to having any interest in. Well, you can't even say apathy again. That you're not interested in not being poisoned. That it's just silly. I mean, bad information is poison to the mind. Because that's all religion is, okay? It's just completely incredible evidence. It just doesn't exist. If it exists, it exists in a form that makes it incredible. It's just stories, just testimony from humans, which can't mean anything. Fish stories about what your granddaddy did or your great granddaddy. Just silly stories. Or you drove a nail in, and none of them can be, replicated. So, God's miracles don't happen in any form we can see. They've never grown a new arm. It's always some other kind of bullshit miracle. There's always a catch Just like the psychics who, can't play the lottery for some special spiritual reason. With his fist. Some story, and we know those are just as incredible as you can get. So you're basically saying, I don't care whether you tell me a fable or whether you attempt to find evidence in the world and explain something. Then you don't see how it's so dangerous. I mean, you could argue that, 1,000 years ago, people already knew the Earth was round because they found the one piece of evidence that's really obvious. The whole land rising out of the sea, with the tall things, which basically tells you the surface is curved. It's not flat. And once you have a curved surface, it's really easy to say, well, it would make sense it would be a sphere then, because just a curve in space wouldn't make much sense. And yes, the little other thing we can see, the moon, yes, sphere makes sense. We know it's not a dime, it's not some flat thing looking at us. And we can see that too based on the shadow and different things. So you can find little pieces of evidence that give you every indication of the truth. And it's a huge difference between that and just making up crap about cheese or something. The moon's made out of cheese. It has some holes in it. Bubbles. I mean, just stupid shit. And you're just basically saying you're apathetic to those distinctions. Yeah, I mean, this is, it's just good reasoning and bad reasoning, and to be, to not care that human beings should do that reasoning carefully and well, not sloppily and malicious even, dishonestly. Come on. Shit. Belief without reason versus belief with reason. With logic, with evidence, with some kind of connection to facts in the world, actual facts, not just made up crap. And you're apathetic. And what am I supposed to say to that? But gee, then you're an asshole. If you're apathetic about how destructive it is to humankind to have wrong perceptions of reality, then you're a jerk, frankly. Yep. True. I would only ask, whatever, if free will is entirely illusionary and only a byproduct of electromagnetic interactions influenced by environmental history, early influences, etc., physics, right. So there's no illusion of it, frankly. If somebody would have told me when I was a kid, think about how you think. Where do you think the thoughts come from? And then you have a thought, and you go through the process of explaining how, oh yeah, it's just a program. Oh yeah, I heard Fred Flintstone say that, SpongeBob said it, like 3 weeks ago. I heard SpongeBob say that. That's where it came from. I mean, you can find where everything comes from. If you think about your thinking process, you can see where your thoughts come from. You can see the origin of them. You can go back to high school and go back to grammar school, or go back to your uncle or your aunt or some other thing, and you can figure out that, oh yeah, that's where I got the first impression. Oh yeah, that's where I gained an appreciation for. Oh yeah, that's when something happened and I gained a sense of empathy because I thought about it for the first time. What if that was me? It's easy. So I don't have any illusion. I didn't have any illusion. All I had was everybody says so. There was no illusion in my brain. There was just the fact that everybody says somehow this is all, whatever it is. I'm making it up as I go along because no one gave me the better answer of, you're just programmed. And by what happens to you in your life, these little events of humiliation and different things that will happen to you are going to change you into a different kind of person. That's why you have to build character. It doesn't just, humans aren't born with character. They aren't born stoic and great. They're born an asshole and they have to be made into something better. Then why does abiogenesis remain a problem? A problem for who? Religious kooks. I mean, a scientist knows, we can't see everything really easy. Okay, so we can't understand how everything works. We can, get a sort of a look at an electron, but it's only sort of a look. It's not can't take a picture of one. and let alone take a picture of the forces, gravity, take a picture of gravity, can't do that, can't blow it up, can't put it under a microscope, because, we have to reflect light off of it, and light doesn't reflect off things this small consistently and all that kind of crap, so we have limitations. So, problem, why would I say it's a problem? I mean, why would I think it's a problem? That there's an evolutionary process, and they're very different evolutionary processes. So let's understand, abiogenesis doesn't even get you to the catch, the bigger story, which is going from single cell living thing to multi-cell living thing. Because every feature about us that has any significance at all has nothing to do with single cell evolution, and has everything to do with building evolution. So it's like, first you have to figure out how the brick was made, and then you have to figure out how you make buildings out of bricks. So to me, if you're going to sit there and say which one's a bigger problem, well, I'd say the multicellular organism is much more interesting a story. Now, that one we can say it's all DNA molecule, because DNA molecules, we watch them build embryos. So we see the evolution. We see pieces of the evolution. We have more evidence, but we don't have more evidence of the actual construction, let's say, of a brain, and how everything connects inside of the brain. So there's lots of mystery still existing about the function of brain, but those questions don't sit there and say, well, we got to answer this or we can't go forward. They're not stumbling blocks, and abiogenesis, in my opinion, isn't any kind of stumbling block. You don't know, it's just a recipe. You do a certain thing to a bucket of chemistry, and you know that it's going to have to create a membrane, and the molecule has to get stuck inside, and somehow the molecule has to modify the membrane just to filter certain chemistry, and it's just going to be a process. And so the original process, the DNA molecule, wasn't just it wasn't using the chemistry to create a Morse code, to create a sequence of events. It was creating actual chemicals that actually stuck to other stuff and actually did things. It was actually hands-on building, where now it's just reading blueprint. So it was more of a worker in the you'd argue in the abiogenesis phase. But there's not going to be some dramatic answer. There's just going to be a recipe of events that make it possible to create. And, I've used this. I've said it before in videos, on the Amendum channel anyway. I mean, I could speculate that, you can watch, foam on the ocean. You can watch waves smashing onto rocks. And you could say, yeah, it makes a lot of sense that you could take, once you've created one of these little pieces of one of these dirty bubbles, a little water droplet, that all you have to do is smash it when it has the DNA in it, and the two water droplets will be formed out of the single one. And that was probably the first replication, was actually the physical environment replicating the molecule. It was actually a physical process of replicating the cell, let's say. And then it became, as it got more and more features, one of the features was it caused its own separation. It divided on its own. It didn't need a mechanical process anymore to divide. But, I mean, having those details is going to change something about understanding free will? Not a chance. Revealed in the field development, so we see how they make the building a little bit. We can take snapshots every 45 seconds and get some idea of how the building is being made. But it's still a big question, okay? I mean, because that's the part that goes into consciousness and all that kind of crap, and the subject of free will and all that shit is part of understanding that abiogenesis doesn't explain consciousness, because that's buildings, that's not bricks. Yeah, so it's the science of understanding how architecture and what'll stand up and what won't and all that kind of stuff. So it's a different kind of thing than brick making. Architecture, making buildings, different than making bricks. All right. Shouldn't some Nobel Prize have been awarded to some young biogenetic genius for imparting life, by extension, mind, thought? I mean, so again, you don't even understand that distinction. That abiogenesis builds you the first little tiny replicating robot. It builds a brick. It doesn't build a building. It's not the Empire State Building. Okay, so not even close to getting there yet. Doesn't do anything. It's a the it, I again will just say it's going to be useless knowledge. It really won't change anything because it's just going to be a recipe, and that's it. It's not going to be fascinating. And the origin of matter in the universe is just the recipe. It's just the fact that the universe, whether you call it error code or something, there's some reason, whatever it is, the nothing, okay, breaks down in some way, and you end up with matter. It's not going to be some miracle story. It's just going to be a mechanical process. And once you understand it, you're going to go, oh yeah, well, that's yeah. It's not going to be. It's not going to fill in any of the blanks. It's the minor chemistry. So we know that it took 25 years to develop a blue LED because there's a trick to it. Just as there's a trick to the creation of the elements inside of the universe, inside of the hot spots, and what temperature the sun has to be to produce gold versus platinum versus something else. And we don't have all that written down perfectly. But, having the perfect knowledge of it isn't going to change your opinion on free will. You have to let the thing cool, and then you have to coat it with some chemical, and then you have to heat the chemical, and then you have to do this, and then it's a process. And nature's had millions, hundreds of millions in the first case, and you could say billions in some cases, of years to create the recipe. To sit there and throw things at the wall and see if they stick. We don't have that kind of time. So and then if you just add up the tiny percentage of the human race that's working on it, it's not enough time spent throwing the crap at the wall and see if you can make it stick. But to say it's some insurmountable problem, we'll never resolve it, it's so magnificently strange and bizarre and blah, blah, blah. No, it's just that it's unusual in the sense that it takes more than one event. It's not just having the DNA molecule. We know that you need another molecule that goes and rips the DNA molecule in half. And that you need another molecule to attach and unattach elements to the DNA molecule. So we know there's more chemistry than just one chemical. Anyway. There's more events than one event. So there has to be a collision of events. It has to be a circumstance, a coincidence of events even, to create the more sophisticated compounds, and to make them to create them in a form where you can replicate their creation, where the process is internal. So this is just to imply that this is the big question. No, it really isn't the big question, because we are the byproduct of lots of evolutions. Not just one evolution. We're the byproduct of first the evolution of matter itself inside of suns, that made the universe into heavier and heavier elements. That evolution had to happen first, and then you have to mix the elements. They have to get scattered through the whole universe. I mean, there's lots of evolutions that have to take place before you even start to make this chemical evolution. Just curious your thinking. Well, that's my thinking. Is it not possible or likely even that consciousness represents something greater than the sum of its parts? So he says he's apathetic on religion. That sounds like somebody looking for a religion. Well, I don't know what else that is. Well, why would I think any of that shit? What shred of evidence gives you reason to believe that there's something greater than the parts? What? I mean, you see how erratic and unfunctional humans are. You see that all you have to do is dent them a little tiny bit, smack them a little too hard when they're a kid and they have an attitude for the rest of their life. You see how controlled they are by stupid and idiotic things. And you're going to make this silly argument that consciousness is special? Some sort of special thing? No. It's a completely vulnerable, and you can see the patterns in it all over the place. It's pretty reliable in terms of predicting. All right, I don't want to really diminish the idea of the theater argument. You know, the fact that our brain has actually created the illusion, okay, of you sitting in a theater watching the performance of your brain. Essentially, your brain takes in raw input in a crude form and projects it to a viewer that reacts to it, and then those reactions are fed back as sensations. And so it is a sophisticated thing, this illusion of consciousness. But in a sense, the illusion part is the fact that we're just sensing it without understanding it. And if you just think about it as being just that, just being a feedback loop, something, a piece of spaghetti that's making spaghetti, or some kind of circumstance like that, where you can just say, yes, okay, it's going to create a something that seems, what's right? I won't come up. There's no good analogies for it, frankly. Beyond just saying that that's what you're really being, that's what's really taking place, is that you have this thing that takes in information, senses, and then you have this seventh sense. You could just argue that is where all the senses are fed into that one sense, as a projection, and by reviewing it in this form, probably not helping any. The key argument is the argument I've made, is that for the biological organism to advance, it needed to store, it needed to gain knowledge from its existence. It needed to learn. And to learn, there has to be some mechanism to reward when you got a right answer and punish when you have a wrong answer. And that's really the key to the whole thing. There had to be some reason, some way to measure the value of a lesson, what you're learning. And so there had to be some mechanism. And so in the process of attempting to synthesize value, nature made the real thing in terms of giving you real sensations that have real characters being positive and negative, or negative and unnegative, which is probably more correct. Anyway, I'm adding an awful lot to this video. It's probably just going to be a video. Probably won't bother with the rest. Anyway, Abiogenesis is still a rather large elephant in the room. I don't know, TNQ, I don't know what that means. To not something. Anyway, just fuck you. Anyway, elephant in the room. So the fact that it's going to take humanity quite a while to sit there and see that, to draw a model of it, is to you surprising. So, how long, which one do you think take longer? To figure out the model of radioactive decay or abiogenesis? And do you think either one, knowing the answer to either one could mean a damn thing, really? Beyond knowing that it happens and understanding that it's just a mechanical process. Yes, that's the difference, is that they really haven't figured out it's just a mechanical process yet for radioactive decay. So it would actually be more significant than abiogenesis would be radioactive decay, because once they knew it was just a mechanical process, they'd understand it doesn't have anything to do with space-time and clocks and all this kind of crap. It has, it's completely an incidental relationship between velocity and some sort of time dimension and all that kind of crap. And it's just the fact that, decayable elements decay more slowly if they have a high velocity. What else do you need to know? You know, I mean, having some details, having some ability, like, you know, I would argue that having the right answer about radioactive decay is going to also include the part where moving a decaying particle, or a particle capable of decaying, actually reduces its capacity to decay, because it you know, relies on a simultaneous event. I mean, having some model makes it then possible for you to understand why there's changes when you change the environment. But it's not going to answer any big questions about the meaning of life or change. Right. So the model of abiogenesis, of creating a replicating machine, you know, okay, because it's more than just the molecule. I mean, it's probably going to be an RNA kind of, you know, blueprint. It's probably not even going to need a DNA molecule to make something that's in some sense replicating and cellular. I mean, the first cellular life form might not have been DNA. It's just that they've all been killed by the new modern DNA molecule. So the only thing left are the remnants in the RNA form, but there are no, you know, the ones that were actually functional as living organisms got wiped out by the, you know, just like the dinosaurs got wiped out. So the original life forms, the original cellular life forms probably don't exist, just like the dinosaurs don't exist, because they got wiped out by the modern, newer, more capable versions of life. Changes from robots into whatever holy things, you know. Again, just, you know, where are you going with this nonsense? You really don't think we evolved on planet Earth from other dumb animals, and that the animals are in fact dumb and programmed and robotic, and there's no spark, you know, of anything in there? They're just feeding machines, replicating a molecule. Anyway, yuck. As a comment, that's my. That's so I answered his question. It was pretty specific to me. It really does change the subject. I don't know if there's any point in leaving it there. I read it. It's in a video now being read and answered. So I'm going to remove it just because it's just going to provoke other people to say something stupid. All right. Likewise with this moronic comment. Quantum physics is bunk. Well, who cares? So says Bolograph Snow, whatever the fuck that means. But you're still wrong about kinetic energy and relativity. Well, you made such a persuasive argument. How can I not be convinced? Bolograph Snow says so. I mean, you just can't see how pathetic this crap is. I mean, I can't imagine. I would think I could just write this on a fucking video somewhere, whether it's politics or any subject. I just write some tripe. I don't think so. There. That's all I have to say, right? I don't think so. And I'm done. Done my job. Fuck you. God. Puke. Ugh. So, I mean, you know, part of this process is just revealing how goddamn base and retarded humans are, that they can't come up with better physics arguments than these. You know, they're defending a theory, and yet they can't, you know, they can't put any facts together, they can't put any analogies together, they can't do anything to defend what they believe. They just believe it. They believe. Because somebody told them so. That's it. There really isn't any good reason for them believing. Alright. So what I think I'll do is just go through some of the simple experiments again, you know, that haven't been done, that, you know, would reveal an awful lot, and, you know, make it clear, give us all a foundation on which to discuss the nature of things, because we would put these facts together like the ground rising out of the sea as you're coming home. You know, little pieces of evidence that indicate a truth. You know, and if we don't agree on those pieces of evidence, if somebody's allowed to say, No, it happens the other way around. You see the close things first. And they poof right into, yeah, I see it. I didn't see it, now I see it. All of it. The whole thing. Anyway, so I'll pause and blackboard, I suppose. Alright, so that's before everything went to hell. And so, yeah, we should pause, and then I'll be back. And hopefully it won't go to hell. Such. Alright, do it the safe way. Anyway, so I don't have a glitch. The simplest experiment, as I've pointed out, the one that would do a lot to fix physics in terms of recognizing what momentum really is, and what weight is, and how it's all connected, and that these quantities of a joule or a watt or a horsepower or all that stuff should really just be converted into some knowledge or understanding that it's an amount of weight that moves from one place to another that's causing the action. So the action is all being caused by momentum. So they have a simple, this is a Newton, all right? Take 100 grams, or 103, whatever the stupid thing is, anyway. And you just put it on a scale, right? You'll put it on a scale, blah, 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 blah. And, 100 grams is a Newton, okay? And then if you want to make a joule, you just take the 100 grams. Now, they would say you lift it 1 meter, okay? But the truth is, okay, that when they say lift it 1 meter, they really mean launch it 1 meter. That is, hit it with a force, okay, that'll make it go 1 meter high and stop. And that force, okay, to make it go up 1 meter and stop, is the same, okay, as a joule or a watt. Okay, so either one of those is the same as the force it takes to launch one. See, because you can't really lift. They say lift, but they really can't mean that. Because if I lift it really slowly, I'm going to have to use a lot of force. I'm going to have to use a lot of joules. Because I'm constantly pushing it. The whole time I'm lifting it, I'm still pushing on it and holding it. So the slower I move it up, the more energy I'm going to use. So it really isn't a very good analogy. It's really a horrible one, frankly. And this is supposed to be, a highly developed and well constructed science. And yet they'll say something like Professor Lewin will actually hold his briefcase and say, I'm not doing any work. Well, yeah, you are. You're doing a lot of work. Your muscles are working, everything. You're going to get fatigued if you do this. You're going to burn calories if you hold it. Just hold it there. So you are doing work, okay, against gravity. And it's a fact. So how fast you move something through gravity decides how much work you have to do. So the faster you can move something, the faster the impulse, the less work you do per meter of distance. So the faster you can launch something, the less per meter work you'll do. But anyway, so it's a trick of gravity. And that's a fact. Sort of like so the buildings rising out of the sea when you're coming home. It's a fact. And it's a really important one to understanding the truth. So anyway, so that's what the force is. The force is launching 100 grams to the height of 1 meter. That's a joule. And that's the same as just dropping the damn thing. Okay, so gravity gives you back exactly what you gave. So by the time it goes 1 meter, it hits the ground at exactly the same force that would initiate it to 1 meter of height. So it has the same force. So we get this force is just this force. And so all we need to do is put this on the scale, right? So now the scale, let me just redraw that over down here. So now we just want to know, so now we want to put a joule or a watt, okay, on this side of the scale, all right? And all we're going to do now is take the 100 grams and drop it, okay, 1 meter, and it will have an impulse, okay? Now, it's not going to stay that weight. It's only going to be an impulse weight So we have to catch it as it falls, you know. So the spring, we watch how far the spring compresses. So we just put it on a spring that compresses, you know. Just make a little scale, drop the butter onto the scale, 1 meter, and the amount the spring stretches, the maximum amount, will tell us exactly what a joule or a watt weighs. That's huge. Okay, that's, knowing that is gigantic, because now we can convert everything into just pounds. You could say pounds of electricity instead of kilowatts. You know, you can just say pounds of electrons moving. You know, the force they apply. Everything could just be converted into a pound, you know, or a kilogram, or however you want to view weight. But that's all it is. It's just weight, okay? Because that's all you really did. You change something's weight by changing the force that acts on it. And clearly in the case where you allow the 100 grams to fall, you're allowing it to gain the velocity. So when it hits, it's not going 9.8 meters per second anymore, right? So when it hits here, it doesn't have just 9.8 meters per second of force hitting it. It has its acquired velocity. And so now it's going to weigh, say, I would argue that the number is going to be something like 230 grams. Okay, that's my guess. Could be way off. But that's the guess that I had for a conversion from newtons into joules. And that's what this gives you. This will give you a direct equivalency between newtons, that is something's weight, and joules. So you'll just be able to say, how much does it weigh? That'll tell you how much energy it has in terms of this current state. It'll tell you what it's capable of doing. Not because you moved it, just because of just its weight. How many joules of energy I'm applying to the ground right now. The answer is, what do I weigh? And that'll tell you the answer. So, I guess it would be 230 plus 100. You know, I mean, that's the tricky part, but you have to add the intrinsic weight to the added velocity weight. So it would be 330. I suppose. Anyway, I mean, I can't do everything. I can't figure out everything for you, so I'm not sure of that number. But anyway, that's the thing to do. It's just to weigh it, see how much it weighs, and I'll tell you what a joule is. And once you have that knowledge, then, like I said, you can take every circumstance. You can take the train, and you could just say, you know, I'm just going to do its mass times its velocity, its momentum. And then I just multiply the momentum number times this number, this ratio, 2.3. Okay, that's going to be the increase. 2.3, and that'll tell me how many joules of energy it is, how many watts it can produce. And it'll be that simple. That seems a lot better. All right, so we'll do another. We'll think of another. So that's just such a simple experiment, and there's no evidence it's ever been done. And it's just so fundamental. I mean, it's a fundamentally, it tells, it's a piece of research, a piece of inquiry that even if you didn't believe it's going to give you a direct equivalency, it'd be damn interesting to know, because basically your whole theory is basically saying this quantity, this energy quantity you're using all the time, joule, is by definition so simply defined as just what is the weight of 100 grams falling 1 meter. And there's no, scientists don't do it all the time, like, oh, this is such a great famous experiment, you know, figuring out how many newtons are in a joule. You know, never done. I'm just saying that's because they've already accepted the flat earth, and they're not even looking at the land rising, and they're not looking at all the evidence that's all around them saying it ain't flat, idiot. Anyway, so I'll be back. All right, another simple experiment. You'd say, gee, somebody should have done this one by now. You know, there should be a record of it somewhere. You know, somewhere, somebody had to do this experiment. So you just take a spring, okay, against a solid surface, and you compress the spring, and now you compress it the same amount, and you just put something that weighs 2x here, 2x of mass, and just 1x of mass over here, and you just measure the velocity as which the object leaves, and you just say this one's going to have 1/2 the velocity, and this one's going to have 1 velocity. That's it. And so they're saying this will have 1.4 the velocity here. Okay, so, oops, wrong way. The fast object, sorry, I had the fast one over here. That this will only be 1.4 the velocity of the heavier object for whatever strange reason. That can't make any sense reason. I guess I could do this as a 1 and this is a 2, and that would make more sense. So this is supposed to be 2x, and it's only 1.4 is their theory. I don't know whose theory it is. Like I said, most physicists I don't think believe that, but some do write papers that have that in the paper. So it's such a simple experiment. Just it seems amazing that nobody's done that. Now, I showed the experiment where they actually have the spring between the two objects. Okay, and I put the 1 mass here, and I put the 2 mass over here, or the 4 mass, so I can put a 2 mass, or a 4 mass, or an 8 mass. It doesn't matter what number I use on this side, I get the same thing on this side. Now I show the experiment where that's basically the truth. The velocity is always the same in this direction. No matter how heavy this gets, this is always half this velocity. I mean, it's always twice this velocity. This velocity is always one. It's always half or a quarter or an eighth, and this side's always the same. Same velocity this way. I showed that with the wooden blocks. That no matter how you stack up 2 blocks, 4 blocks, 3 blocks, 4 blocks, no matter how many blocks you stack up on this side, make it heavier and heavier, this side does the same thing at the same velocity. But we don't have the experiment in real good form, well done. The other one was just rubber bands. It's a different thing, blah, blah, blah. But anyway, it's just a simple experiment, and yet we don't have it. And you got to say, well, why? Because physics can't use it. Because the answer it's going to give is going to be, it's going to break intuition with mv squared. Mv squared isn't going to be able to be made sensible, okay, vmv, to be more explicitly accurate. It's not going to make sense when you see it actually happening. That's not going to happen. This 1.4 won't happen. Now the trick is the spring. When you do the experiment, there's a trick to springs. So if the spring is a little bit soft, that is, it has a lot of windings and is kind of mushy, it's going to move slower. Its maximum velocity, okay, is slower than a stiff spring, okay, with fewer coils, thicker, harder spring. So the harder spring will move less. So it's a little harder to measure because it moves less, but it moves much faster, okay, so it has a maximum velocity that's very high, where this has a slow velocity. And you need the velocity to be fast enough to actually push the energy, get the energy into the object. So the spring has to have enough speed to be able to impart speed onto something. It has to be able to push faster than the object is going to have to move for you to get the energy into it. And that's why big things can't push little things. I mean, a big thing with a 2 mass, can't push the small mass, can't put its energy into the small mass because it can't give it more velocity than it has. It has a certain velocity, and unless I make it more elastic, that is, I give it a spring, I can't make this go faster than this is going. I can only make it faster if I put a spring in here, some kind of rubber ball or something that compresses and re-expands, so I can then compress that, push the thing, and then have the spring expand and add extra velocity. So I can't make big things give their energy to small things unless I create an intermediate device. And I pointed out that you could do that with a lever. You could just so the other simple experiment is just to take a lever and just drop weights on it. okay, and at different places, and see if you get a different amount of energy back out. So just weigh, 50 pounds here on the lever versus 50 pounds here on the lever. And does the lever produce, at this location 50 pounds for this, and then 100 pounds for this? So if I measure it from here, does this out here on the lever weigh 100 pounds here? Or is it 1.4 or some other kind of nonsense? Is there any difference? Is there any physical difference between the weight of these two objects? And there should be. Like I said, the 50 pounds out here should be double the weight of torque here, because you're going to move this twice as much as you're going to move this, okay, in the same amount of time. And so this is obviously going to move faster, okay, than this, because this is going more distance. So another experiment, simple, no video, no references, no place I can take you. So again, I've pleaded for months now for somebody to give me a link to experimental evidence for the kinetic energy theory, for this VMV thing. Where's the place where they collect the extra energy? They say the 5-ton train going 10 miles an hour has twice as much energy as a 10-ton train going 5 miles an hour. Well, why isn't there a single experiment showing that those are inverted mass to velocity ratios showing twice as much energy? There should be. You could argue. After all this time, nobody's done the experiment? And they're so simple, just levers and springs. So anyway, I could go to the third one where the Professor Lewin added momentum one, but yeah, we'll just leave that paradox for another day. But it's another experiment that certainly all you have to do is redo the experiment a couple of times in sequence, and you could end up creating 3 times as much, 4 times as much momentum, and that's essentially free energy, because weight is energy. And that's the way it works. Mass is an energy. Weight is energy, because weight is mass in motion. That's what gravity does. It moves you into the scale. Fact. Okay, your movement is what compresses the spring in the scale. Fact. Anyway. Alright, so that's probably enough of a video. So, yeah, we'll leave it there. And so, this is the button I press, right? Yeah, I think so. So this has been a DraftScience video presentation. So till the next time and such and so forth and whatnot. Blah, 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 blah.